Uh, Welcome, everyone, to another great Work It Wednesday. I'm Paula Houghton. I'm the Director of Special Projects at Foundations, Inc. We're the organization that's responsible for the Beyond School Hours National Education Conference. And these Work It Wednesdays are our way of bringing you a little bit of Beyond School Hours at home all year long. Today, we are joined by Rich Stuart from Learning Wrap-Ups, and he'll be talking about how fact fluency is an important foundation to higher level math and how after school and summer programs can be a key part to building that foundation. Registration for our conference is open now, and you can find out more about that or register for future Work It Wednesdays by following the links that I'm about to post in the chat. And now, without any further ado, here's Rich.
Hello. Hey, those of you that are signed in without the video, I'd love to see faces. So if you don't mind turning on your video, I'm going to go to, I've got a little presentation with on PowerPoint, but we can go back and forth. And by all means, if you have a question or comment that you want to share, I would love to entertain all of those ideas. Okay. All right. Let me go to share screen. And go back to here. How do I show everybody, Michelle? That one? Okay. All right. Can you see the first screen there? After school can develop fact fluency. All right. This is, first of all, what's the definition of fact fluency? Anybody with that dares turn on their audio? I want to hear a couple of thoughts on that.
Being able to derive facts, math facts, in relatively quick time frame.
That's really, really close. The ability to recall and answer basic facts automatically without hesitation. If you're truly fluent, you can come up with these answers without any extra mental effort. We don't have to pull out our hands and count our fingers. We just tell you what the answer is. And the real question is that important? And why? I think students should be able to know that, but there's different philosophies on that in the school system. So a lot of educators will call that type of thing drill and kill. And if we spend all of our efforts on memorizing facts so that we can recall them easily, we lose a lot of kids along the way. But at the same time, when they only focus on concepts, they never get the basic math facts down, and it makes it challenging for the middle school teachers. I've got a quote here from an educational consultant I like to follow, Amy Yermish. She says, it's going to be very difficult to get to graduate level mathematics if you can't hack calculus, because you couldn't hack algebra, because you couldn't hack middle school math, because you couldn't hack arithmetic. And those second, third, fourth graders, those years where we focus on these basic skills, if you find a second, third, or fourth grader who has automatic recall of addition, subtraction, multiplication, and division, those kids are so much further ahead. And when they get to middle school math, they're not going to be struggling with the pre-algebra. And that allows them to get on that ladder to go from pre-algebra to algebra to geometry to algebra 2 and calculus and trig and so on up the line. Teachers, they're faced with a lot of issues. And some of the things that make it difficult for them in there is, let's be honest, math fact practice is not always necessarily the most fun thing to do. Every student in the classroom is at a different level. You got some kids that catch on pretty quickly, some that catch on with a lot of work, and some that just are going to have to work really, really hard at it. Sometimes we don't get the support from home. Time restraints, tight schedules. Those teachers have to cover what the textbook teaches them, and they've got to go from chapter to chapter to chapter to get things done. And at some point, they just have to move on. They really don't have time to focus on that. And if you go to a middle school teacher, high school, or even college professors, you ask them what some of their biggest challenges are, they'll tell you the kids spend way too much time on simple equations. They use calculators for things that are simple parts of the problems, and they use up all their mental effort on the simple part of the problems, and they lose focus when it actually comes to what's being taught. All right. This, I'm going to try to tell you a little side story, a little personal thing here. This slide that you see here is Troy Kemp. In 1995, he represented the Bahamas at the World Track and Field Championships in Sweden. Why would I be talking about Troy Kemp? Well, Troy Kemp is kind of one of my heroes. He actually won the World Championships that year. He jumped 2.37 meters, which equates to 7 feet 9¼ inches. Second place that year was a Cuban high jumper named Javier Sotomayor. And if you are any kind of a track fan, you know that Javier Sotomayor holds the world record, and it's one of the oldest track and field world records. He holds the record at 8 feet 1/2 inch. That year, though, Troy Kemp took first, Javier Sotomayor took second. All right, got another picture for you. Any guess who that might be? See any resemblance? That's me. Back in 1986, when I was in college, I was on the track team for Weber State. And this is a picture that was in the school newspaper. This was the Snake River Open and at a meet up at Idaho State in Pocatello, Idaho. I took first place that day. I didn't jump as high as what Troy did in the World Championship, but I did clear 2.11 meters, which is 6 feet 11 inches. Okay. Troy Kemp was also in that meet. He took second place. He was a world champion 9 years later, but on that day, he took second place to me. Let me show you one more slide here. He jumped at Boise State. We were in the same conference. Boise State's moved on to a bigger conference since then, but probably in our years of indoor and outdoor track, we probably competed against each other 10 to 15 times. Every time we competed, besides that one meet, Troy took first place, I did not. Every time we competed, Troy was way over 7 feet. I just caught him on a day where he didn't have his best stuff. On that day when I did beat him, we both cleared 6 feet 11. They raised the bar to 7 feet 1. Neither one of us made it, but I made 6'11" on my first try. He made it on his second. So anyway, why am I talking about the high jump? There's a lot of things that go into the high jump. My starting point was 12 feet to the right side as I'm looking at the bar, to the right side of the left standard. I would take my measuring tape. From that point, I would go 52 feet back. I'd put a piece of tape on the ground. I would take a 10-step approach. And on my 5th step, my left leg would cross over the right leg, and I'd begin my turn to do the Fosbury flop. My last step was with my left foot. I'd plant that. I'd come in at about a 30-degree angle with my body, throw my arms up, arch my back, try to keep my hips up, and then kick my feet over. There's a lot to it that we don't think about. But I had practiced hundreds, if not thousands of times that approach. I didn't have to think about anything. Once I got my mark, I put the tape down and my only thought was to run up there and jump as high as I can. But because I had practiced and practiced and practiced, those things became automatic. All right. We got a little game that makes that practice a whole lot of fun. And just by show of hands, how many of you are familiar with the learning wrap-ups? I see a couple. All right. Jennifer was out of screen, but she got back in screen. I appreciate that. Let me show you how they work real fast. And I'm gonna, how do I get back to stop share? Okay, there I am. All right, do we want to do the spotlight thing? How do I do that, Michelle?
Up there. Oh, hold on.
I have my daughter here who is going to have a baby in a few weeks as my technical assistant. There we go. Okay, you can see I've got a different key for every times table, 1 through 10. And if I want to work on my nines, I single out the times 9 key. I have questions on the left. For all the 1 through 12 in random order, I have the answers for the nines on the right. So starting at the top, the first question is 9 multiplied by 9. 9 times 9 is 81. That happens to be straight across. The second one is 1 times 9. And then 12 times 9 is 108. And I just work my way down the left side. And if I do it correctly, there are lines on the back that the string will cover. That tells the kids that they've done it right without having to turn a worksheet into the teacher. Let's go back to share screen. Okay. They are, let me do it here. Huh?
Just keep talking.
Okay. They're hands-on. They're different than most methods of practice. There's different ways to use them. There we go.
We're not sharing the screen right now.
Sorry about this. Okay, now we're back here. There's the lines on the back. Okay, every one of those patterns is different on every key. The problems are in a different order, and so we don't memorize a pattern and repeat it over and over again. It's hard to cheat. You can't just cover the lines on the back because the questions are on the left side. And a lot of times if you turn it over to cover the lines, the kids will work down the left side, but the left side is actually the right side when you turn it over. And if you know your times tables well, let me show you an example of some of the things that you can do. This is another thing that we have here. 384 there with the orange dot with the hole in it. We've got 277 times 532 is a solid orange dot, but the one with the hole in it we call a donut, and the solid ones we call cookies. 384 times 325. That's a big problem. Kids are reaching for their calculators. But look how simple this is. I'm going to call 384 400. And I'm going to call 325 300. I'm going to make it a little easier than that. If I know 3 times 4 is 12, I have enough information to find the answer. 3 times 4 is 12, and then there are 2 digits beyond the 2 numbers we're estimating. So I take 12 and I add 4 digits because there's 2 on each problem. 12 with 4 digits is 120,000. 4 times 5, the last 2 digits of each problem is 20. So I know that the answer has to end in 0. So looking around that circle, try to find me something that's around 120,000 that ends in 0. Do you see the answers?
124,800.
Janita, am I saying that correct?
Yes, sir.
Very good. I'm going to put you on the spot. Let's do the blue donut. What's 920 times 302?
So that's going to be 900 times 300, which is 27.
27 with 4 digits.
4 digits. So I'm going to say 277,840.
It ends in 0 because 0 times 2 is 2. 277,840 is a logical answer. Now, there's some that get you in the ballpark. For example, the blue cookie, the solid blue one, 413 times 102. That's somewhere around 40,000. And the purple cookie is 200 times 200. That's around 40,000. But the blue one ends in 6 because 3 times 2 is 6. So that the blue one would be down here at 42,006. The purple donut would be 40,874 because we can differentiate that. But just by knowing and having that automatic recall to simple facts, we know enough to find the answer that makes the most sense. It's a pretty incredible thing. So we use these discs to answer the questions. See, the orange donut would go there, and when you turn the card over, there's a color band that matches up to each color disc, and you can get your answers. We have both a hands-on version and an internet version. And the good news is the internet version, we decided once this pandemic started, we needed to do something to help everybody out. And so we decided to offer the internet version of our learning palette completely for free. Stop that. This cute little girl right here is my daughter, and she's actually here today to help me out. We've been using this photo for a long time. She's married, has a 4-year-old, soon to be 5-year-old daughter, and has another little boy that's going to be here next month. She is very pregnant today, but what a cute photo we have of her, and I appreciate her coming to help me out. There are hundreds of these activity cards. See the 2 dots? Can you see my mouse when I'm doing that? Okay. The 2 dots here indicate the grade level. So that means this is 2nd grade. We're dealing with fractions. This is the 11th of 12 cards. So I would take this yellow disc. There's my yellow problem, 2/6, and I'm finding the equivalent measurement. 2/6 is the same as 1/3 because I can see that they take up the same amount of space. When you turn the card over, the yellow disc goes with the solid yellow line, and I can see a review of the question. 2/6 and 1/3 are the same thing. So the kids get that immediate feedback. I got a note here. I'd like to tell a story about a 3rd grade teacher on an airplane. I'm going to a conference years ago, and as soon as we get up to altitude, you get the ding, you can get out of your seats. And the gal next to me reached up to the overhead and pulled out her bag, and she opened up about 4 or 5 inches worth of homework. So curious, I said, so you're a teacher, what grade do you teach? She tells me she teaches 3rd grade, and I watch her as she corrects these papers. She had 4 or 5 inches of homework that had been handed in that the kids had no idea how they did. Luckily, as I watched it, most of the students did really well. She had a lot of smiley faces and 100%, but those kids need to know that they did good right away, or if they have a mistake, they can fix it and move on. There's reading skills. Let's see. What pet, see the purple disc right here with the hole in it, the purple donut? What pet is always on the floor? That would be a carpet. This is from the 2nd grade reading comprehension. So we have some that we have a little bit of fun. An animal that doesn't follow the rules. The yellow donut would come up here to a cheetah. And when you flip it over, there's the answers on the back. Here's just a few examples of cards. This is the star indicates kindergarten. This is the 11th of 12 cards in the kindergarten series. The missing number here with the purple cookie is 5. So I'd take the purple disc and place it right up there next to the 5. I can do it backwards. I can find 99 starting with the answer, and I know that 99's got to be toward the end. So I look here and I find that there's the purple cooked donut, and then I place the purple donut right here by 99, and that gives you that automatic feedback. All right. This is second grade geometry and measurement. You got conversions for length and weight and volume. 2 pints is the same as a quart. 4 quarts makes a gallon, 2 cups makes a pint, and 1 cup is the same as 8 ounces. There's your answers on the back. Multiplication for third graders. They're getting to see arrays or columns and rows, and they can literally count to find the answers, count the number of squares, and they get the concepts. Finding points on the number line. This is 4th grade numeration. Between 0 and 1, this one's divided by 4ths, this one's by 6ths, this is by 8ths and 10ths. And finding the missing angles. These ones here on the bottom are 180-degree straight angles. So if 90 degrees is shown, I take 180 degrees for the straight angle, subtract 90, and the missing angle is also 90 degrees. The ones up on the top are 90-degree right angles. So I have 90 degrees here with 55 shown. 90 minus 55 would be 35 degrees. And I take the red cookie, place it right there, and there's your answer on the back. All right. I need a volunteer to help me with this one. Somebody that's brave and willing to try 4th grade algebra. This, I'm just showing you one portion of the card. We're trying to find the unknown value for a circle, the square, and the triangle. One of the shapes is worth 2, one of them is worth 5, and one of them is worth 4. Anybody brave enough to tackle this? Janita, I'm gonna coach you through it. Turn off or turn your mic,
Okay.
there you go. Okay, I'm gonna give you a little hint.
I got the first one. The
Go ahead.
Okay, you said the circle, square, and rectangle each have their own value, correct?
That's correct, and it's one of those 3 numbers. So you just need to assign the right number to each shape.
Okay, so now I lost it. Okay, because that's not going to work.
Okay, let me help you out. There's more than one square.
The first one.
Can I give it a
Can
try?
I say the circle?
Say that again.
The circles are going to be 2, and the square is going to be 5. So the first one is 2 plus 2 because there's 2 circles, correct? Or is that just...
The top one is a circle and a square equals 9. And I'm asking, using the red one, to find the value of the circle. So,
the colors were confusing me inside.
Okay.
So
the discs represent the value of each shape. So the first question is circle plus square equals 9.
Can I give it a try?
Go ahead.
Okay, so the way I'm looking at it, I'm seeing that I'm going to use the second one to start off with because I know the 8 is in there. And the top one, they both going to be a 4. So I'm going to say that maybe
2 squares would be the same value, right?
Right. So I'm going to say the squares are 4. So 4 plus 4.
4 make 8. That's the only option it can be. So you are 100% correct in your observation. Now go back to the first one. We know that the square is 4. So what does the circle have to be?
5.
And if the square is 4, what's the value of the triangle?
9. I'm sorry. 5, 1. No, 4, 2.
There you
2.
go. So
2.
we solved the one that gives us enough information. And then when you flip the card over, as part of the review, we see that both squares, all of the squares, I keep pointing with my finger, all the squares would have the same value in their 4. Okay, here's another way to solve, to do this. We know that the biggest number, let me go back one. Okay, the biggest sum would have to have the biggest add-in, right? And the smallest sum would have to be associated with the smallest add-in. But the way that you solved it is, I think, the way that we want to do it. We don't have enough information to solve this first one. We know that 4 and 5 make 9, but which shape is 4, which shape is 5? We don't know. There's not enough information there to do that. But if you come down here, 2 squares, the only option for squares has to be 8. So good job. That is the 12th of 12 cards in the level 4 or 4th grade algebra. In all, there are just shy of 8,000 questions and answers. The math curriculum goes K to 5 and the reading curriculum goes K to 3. It's all hands-on. It's interchangeable. There's lots of bases. We have smaller kits for grade levels, or you got bigger kits. But the thing that we're most excited about is this internet version is free for everyone. There's no sign up. There's no, all you need to do to log in is enter your email address, first name and last name. You click on go, and it'll take you to a page like this. Here I have my math tab, which populates all of the grade levels for math. If I click on the reading tab, it would populate the same grade levels. But here, I pre-selected level 1. And then when you click level 1, there's 6 packets of 12 cards for level 1. So here I highlighted the numeration step 3, and then that populates the 12 activity cards in numeration step 3, which deals with money and simple fractions. So I highlight the card 4, how much is shaded. I click on load, and it pulls up this card. And all we do is drag these discs from the question side over here. So the blue one here represents this one. So in this little quadrant here, that area represents a half. The green donut is 1 out of 3, and the red donut is 1 out of 4. So you answer all the questions with the disc. It'll bring up this, are you done? You click on yes, and then it turns it over and gives you your feedback. It took me 2 minutes and 34 seconds to do that, but I got all of them right. And there are literally hundreds, and there's almost 600 activity cards that are unique. Kids just go to the level that they want, and they work really well with laptops or desktop computers. They're pretty good on tablets. You got to move things around. There's a lot of information to be shown, so they're not that great on phones, I'll tell you that. The hands-on version, they have these lid that keeps everything in place, so when you put them away, we don't lose the little pieces. This knob here in the middle screws the lid down tight so that it...
There's a question.
Yeah.
How can we use the after-school space to support math fluency with or without this product?
I got a couple of other things. Just the one, getting back to that, the classrooms don't practice the fluency as much as they'd like. And so in after school, you've got a little more flexibility. You can focus on basic facts. And whether it's with flashcards or wrap-ups or any other practice methods that you've got, you can have all kinds of verbal quizzes going and have kids stand up, the drill sheets, any of those things that give them that automatic recall that you're looking for. That is the focus that you can do. I I want to talk about how we get it to actual fluency. This is an article from the Wall Street Journal. There was a college professor in engineering. She says, one of my engineering students recently approached me with a mixture of anger and befuddlement. Thrusting toward me a quiz sheet covered with red pen marks, he said, I just don't see how I could have done so poorly. I understood it when you taught it in class. He understood the concepts. And she goes on to say, achieving conceptual understanding doesn't mean true mastery. For that, you need practice. And that's what After School can do, is provide a method, or provide the time to get that practice in. How do we get better at piano, at being a better artist, or gymnastics, or being a better dancer? All of these things require time on task, practice, practice, practice.
Can I ask a question?
Yeah.
Okay, so to sign up for this, you need an email. Would each student have to sign in with their email to be able to do it, or would the teacher be able to do it and then just allow the students to use her email?
Both. If they don't have their own individual emails, they can sign in with, and it actually works so the same user account can be used on different machines.
Okay.
So if you're more comfortable letting them use your email address, that's fine. If they happen to have their own, that works just as well too. Okay, and it's the one thing we tried to market this for years as a subscription program, and it was a lot of work. There's so many subscription programs. We just decided, you know what, we've invested all this time and effort into it. We're having a hard time getting a return. Let's just give it away for free. And this isn't a short-term thing. We decided that that's part of the strategy. We want to score some points. And so all I got to do is know how to spell learning palette. Learning that palette is P-A-L, 1 L-E-T-T, 2 T's and an E on the end. Once you have that, you can do that. But getting back to the basic practice methods, what are some of the things you guys use besides wrap-ups to help kids get that fluency, that automatic recall that we were talking about? Has this been a focus? I got a question that came up. How does it support the conceptual understanding? The conceptual part is covered really well in Learning Palette. We have thousands of questions and answers that deal with that, but more than that, the conceptual part is what the classroom teachers cover. That's, to a lot of people, that's what the kids get. They get more conceptual and not enough practice. And so that's where we kind of think that having the whole idea, and the conceptual stuff is 12 times tables, for example. We want to memorize those, but 12s are not as hard as we make them out to be. 12s are a combination of 10s and 2s. 10s are really easy. 6 times 12, think about a 6 times 10, that's 60. Well, the part that's left over from the 12 is 2. 2 times 6 is 12. 6 times 10 is 60. 6 times 2 is 12. Therefore, 6 times 12 is 16. 12 makes 72. That's part of the conceptual understanding. And if you break things apart like that, it could work. You're getting some links for other ideas. A lot of comments about flashcards. Flashcards are great. Sometimes the challenge is they're not as fun. They don't keep kids' interest, but any tool you can use to get that practice and repetition is an effective method. I got another one here. This is a friend of ours, the marker board people. And the little backstory on this one is I went to a parent-teacher conference for my son, and they had this little spider web looking thing as part of their homework. And I thought this was really clever. The one that his teacher had the inside of this circle was blank. And so you could put in any multiplication table you liked. And we actually used it in one of our publications. But we go to a lot of these conferences, and the marker board people have these great marker boards. And I showed them, I said, look, if you put these spider webs, this is a great way to practice. So they have a wipe marker, and you can actually go through and write the answers around. This is a reproducible drill sheet, kind of a flashcard activity. And when you're done, you wipe it off and do it all over again. They actually have them for addition, subtraction, multiply, divide. And if they're of interest, markerboardpeople.com, I've got their phone number listed on the bottom. This is not my product. We don't get anything for it, but it's one that I like because it's a fun method of practice. You can make note of that. All right. Sometimes, going back to the concept and building strategies, we've got a program called 10 Days to Multiplication Mastery. We have similar ones for addition, subtraction, and division, but it basically starts off with the 12 by 12 multiplication chart. This is on page 2 of a workbook, and day 1, we emphasize commutative properties in everything that we do. Commutative properties say that 7 times 2 and 2 times 7 are the same thing. So if we learn our 1s and 2s, we do it horizontally and vertically to illustrate commutative properties. Just by knowing your 1s and 2s, that's 44 questions and answers. And this strategy helps show kids that there's not as much to learn as they think, because by knowing 2 really simple facts, that's almost 1/3 of all the multiplication tables. The next day we practice our 10s. 10s are easy. Add a 0 to it and you've got it. 3s take a little practice, but by doing the 10s and 3s, that's 36 new problems. We pick up, add that to the ones we did previously, you're up to 80, you're way over halfway done. And we haven't done a hard one yet. Then we do the 11s, and then we do the 4s. 11s are easy. 4s take a little practice. We add those in there. We're up to 108. We've only got 36 squares left to fill in. Then we do the 5s. The 5s are easy. And the perfect squares. Then we do 6s. And this is what some of the activities are involved in the book. 7 times 6 and 6 times 7 are both 42. And we got bookshelves that illustrate 7 books on 6 shelves is the same as 6 books on 7 shelves. We introduce the facts with their commutative partners in skip counting order. So if they get stuck, they can just go to the one previous and add 6 to it to get the next answer. Here at the bottom, you write out the questions in number sentence form. 6 times 3 is 18, 3 times 6 is 18, 6 times 4, 24. And then you do your wrap up 5 times as fast as you can. And notice as they practice, the times get a little faster each time. Now we take a written test, and these little highlighted squares represent all of the commutative partners of the 6s that we learned when we did our 1s, 2s, 10s, 3s, 11s. So really the only new facts we're picking up are the 7s, the 8s, 9s, and 12s. Everything else has already been covered. They're all part of the review. Then you do your wrap up 10 more times. You get practice and repetition. You do another written test. You try to do it faster than you did the time before. Do your wrap up 10 more times. Do another written test. There's a lot of practice involved in this. And it's actually, if you do all the activities, it's 32 times of repetition. You do something 32 times, you start to remember it. All right. Now, when you get to the chart, you go back and you fill in the 6s right here, horizontally and vertically. And how many questions do we have left? We got these 6 right here, and we've got these 6 right here. So there's 12 squares left, but these are the same as these ones, so there's only 6 new facts to learn. And then you learn your 7s and your 9s and your 8s and your 12s, and that's day 9 and 10 of the program. You do a lot of review and you have a party. The one thing is that allows you to do is to develop those strategies so that you can build off of your previous successes. All right. Anybody, by show of hands, heard of Jaska Heifetz? He was probably the top violinist in the world many, many years ago. And he was stopped on the streets in New York. Somebody came up to him and said, "Pardon me, sir, how do I get to Carnegie Hall?" Carnegie Hall's just pretty close to Central Park on 7th Avenue. And he said, "Practice, practice, practice." We just can't substitute all the practice. He did say, "If I don't practice one day, I know it. 2 days, the critics know it. 3 days, the public can tell." So if top violinist in the world, if he takes 3 days off, he thinks that you and I could know that he hasn't been practicing. All right. This is a little story that I was doing the West Virginia Afterschool conference years ago. And when we went to unload, they had some volunteers to help us get stuff from our vehicle up to the exhibit area. And Sean Green was a high school kid that was there to help. And as I started to unload, he recognized some of the wrap-ups and he said, "Hey, we always used to race with these things." And he says, "I never won." And I started to feel bad for him. But then he smiled. He says, "But I always got them right." So that's one thing is you do any of the activities you have, we want to emphasize the success of getting them correct more than the speed, because the speed, obviously some kids are going to do better than others. And so I'm trying to sum it up a little bit. There have been studies that show if you get kids in high school that get through Algebra 2, their chances of graduating from college are more than doubled. And the question is, how do we get them to Algebra 2? We got to get them on that ladder that starts with the basic facts. Students who know their, let me come back here. Students who know their basic math facts really well are more than twice as likely to get to Algebra 2. That's my opinion. All right. I'm going to come back to this. There was a study in George W. Bush's administration. They spent a lot of money and years of research to prepare this report called Foundations for Success. And one of the things right at the end of it.
There's a question.
Got a question.
How can I apply the strategies presented here without specifically using this tool?
I can send you the order of problems so you can build off the success. Again, this tool that I shared is a practice method. Any practice method can be applied. Flashcards, drill sheets, written tests, games, running around, letting kids quiz each other. It is the mission, the goal of this is to help you understand that this is such an important part of kids being successful and moving up the ladder to higher level mathematics. If they have that immediate recall, use any method of practice, but use the time and after school to let them do the practice and repetition that they don't necessarily get in the classroom. And back to this study, what we should use from rigorous research is clearly shown about how children learn is that effort, not just inherent talent, counts in mathematical achievement. How do these tasks promote reasoning? I think that gets back to the triple digit multiplication. If you have those basic facts in place, you can do estimation. You can ask yourself if an answer is logical. A lot of times we use the calculator to do more complicated problems. And if you're like me, you got chubby fingers that don't always hit the right key. If I have great recall of my basic math facts and I make a mistake as I'm entering in the data, I can look at the answer and say, wait a second, something doesn't look right. I can't just blindly accept what the calculator spits out. And that frees you up to do the logical. Are these answers logical? I want to open this up for a second. What's after school going to look like next year? Obviously, we've had a lot of changes. I was told by a friend who's got kids in the Boston area that they've been told that they can't have more than 10 students in a classroom at any given time. How many of you are truly confident that we're actually going to have kids in one physical place in after school? Is that what we're planning on? Or are we coming up with other alternatives to help them with use at home? I'm curious on that. If somebody's got some thoughts and wants to turn their microphone on, I'd love to hear some of your plans or what you think it's going to look like and what.
Or chime in the chat as well if you don't have a microphone.
Jessica, from the foundation's point of view, what are we trying to help people prepare for?
I don't think the answer has been revealed yet. I don't think we know what's happening in schools. So I think it's still very dependent on what's, happening with the pandemic.
Yep.
But we should be prepared for multiple possibilities, which could include a hybrid, could include solely virtual, could include some physically present, some not.
I think we got invited to do this because I shared a virtual space with the foundation's people at the Texas After School program, and we made a decision. Let me get off of this here. Stop sharing. All right.
Here's the questions and stuff. Or the chat.
We've got a response in the chat here
Yeah.
too from Jennifer. I know that I have a lot of kiddos that are going virtual schooling for the upcoming school year, and we're doing after school at
all times of the day, every day. So having activities that they can do at home is something that we want to consider. For the folks in the Texas After School programs, we decided again that we want to be in a position to just help because these are unique times. And these little sets of wrap-ups, they're available in big kits, but individually they usually sell for $10 a set. If you were to go on Amazon, you can get them for $10. The workbooks that we talked about with all the lesson plans and community partners, they're $7.50. But the one option so that it can be used at home, we've decided to make the kit together for the same price as the book. So instead of $17.50, you can get these for use at home, a wrap up and the book for a total of $7.50. And they're available for all 4 operations: add, subtract, multiply, and divide. And the idea is these are such unique times that we need activities for kids to do at home that are hands-on. The virtual stuff is great, but we lose kids if they're on the computer all day. Having that hands-on experience gives them that opportunity. So that's one of the things that, let me come here real quick. You get this is something that our stuff, if you're around, as you can see it, it's available through a number of different vendors. This offer for $750 for the book and the set of wrap-ups is so underpriced that that's less than the wholesale price that we would sell it to any of our customers for. So if you think that that is something that could be of interest to your kiddos for use at home, that's something that you need to reach out to me and just say, look, how many of these do we need? We can pack them up. They would come to you in bulk form, so the books would all be packaged together. The wrap-ups would be packaged together. Potentially, we could ship them out to the individual houses. However, that would cost way too much. So if we can ship them to one address and get a little help with the distribution to the students, or if they can make arrangements to come to the school and pick them up, that would be the ideal way. Oh, here's the offer with the individual workbooks. Sorry about that. To show that this isn't just drill memorization only, every single lesson plan starts with the conceptual concept.
That's
We're
good.
showing that 2 times 5 and 5 times 2 are the same thing, because if you have 5 banks with 2 versus 2 banks with 5, they're both 10. There's a conceptual understanding in every lesson, because that is absolutely critical. A combination of the two, though, would be an ideal situation.
Once you understand the concept, it's easiest to, that's when you learn how to memorize it. And then once you understand the concept and you have those facts memorized, it's easier to do like the bigger problems and stuff when you have the basic facts memorized. But you can't memorize anything until you understand the concept. I don't think memorizing something without understanding the concept is useful at all.
Yeah.
That's why you got to understand the concept first.
And there's some comments about different learning styles. Absolutely, different kids are going to respond to different things. It may not be the complete answer for every student, but I tell you what, it's a good answer for a lot of them. And so anyway, there are just some really good opportunities to add some of the things that can assist something that's very measurable. If we can help kids with the combination of conceptual understanding and quick and automatic retention, those kids are definitely going to be in an advantage as they go into the middle school and as we send them on to the upper grades. The 5th and 6th grade teachers will go down to the 3rd grade teachers and say, thank you. You get a whole group that is really struggling with those facts. They're going to keep struggling for the rest of their math careers. I see some links. Anyway, any other thoughts? I think my time is about used up. I really appreciate this opportunity to share some ideas with you, and I'm gonna send some links and some PDFs as part of a follow-up email. If you want to reach out to me, I'd love to put together some thoughts for you to help you do your jobs a little better. Okay.
All right, thanks so much, Rich. We're going to be sending out a follow-up email soon. Rich will have some resources also in there. And next week, we'll have a webinar on simple summer activities for families that focus on wellness, both physical and mental wellness. I just put a link in the chat if anyone wants to register for that. And don't forget also to check out our Beyond School Hours website. And we hope that we see you all next week. Thanks so much for attending.
Thank you.